Hey guys, I'm Jay. Today is my LeetCode review one-take vlog on 124th problem. Binary tree maximum path sum. A path in the binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. We have to note that the path doesn't need to pass through the root. The path sum of a path is the sum of the node's value in the path. We are given the root of a binary tree. We have to return the maximum path sum of any non-empty path. Let's see example 1 here to understand this problem easily. For this binary tree here, the optimal path is 2 points to 1 and points to 3 with a path sum of 6. And let's see example 2 here. The optimal path is 15 points to 20 and points to 7 with a path sum of 42. The reason that why we didn't pick up the root node is because the root node is negative. Then let's get started with our intuition and main idea to solve the problem. Intuition. So the key challenge of this problem is that the path can start and end and at each node, and it can span both the left and the right subtrees of any node in the tree. So we need to explore all the potential paths that can give us the maximum path sum. And we'll solve this problem using a recursive depth-first search approach. And for each node, we'll calculate the maximum path sum from its left and right subtree, and then we'll calculate the potential maximum path sum passing through this node and update our global maximum path sum. Then, let's get started with our first line of code. First, we need to create a variable to help us solve the problem. Let's say private integer max sum. And inside the max path sum method, first we have to initialize the max sum variable to a very small number to handle the negative values in the binary tree. So the code is max sum is assigned to a very small number in the negative in the integer range. And the code is integer dot mean value. And then we'll call a helper function to start the depth-first search traversal from the root node. And we'll update the max sum variable inside this recursion method. Let's call the helper method as DFS, which stands for the depth-first search. And we have to pass the root node into the method. And after the recursion, finally, we just return the updated global maximum path sum. And code is return max sum. Then we have to create and implement the DFS helper method. So the code is private integer and the name of this method DFS, and the method needs an input parameter which is a tree node. And inside the method body, first we have to handle a bad case. If the node is null, we just return 0. Secondly, we will recursively calculate the maximum path sum from the left subtree and the right subtree. So the code is integer left subtree path sum equals. Then we have to recursively call the DFS method to get the maximum path sum from the left subtree. So the code is DFS of the node dot left. But there's one thing we have to remember. The the number of any node can be negative. So if the left subtree path sum is negative, we have to ignore this left subtree by taking the number 0. So we have to implement a limitation between the value of DFS of node left and 0. So the code is math.max of DFS of node left and 0. We have to take the bigger one, and it's very similar for the right subtree. So the code is integer right path sum equals math.max of DFS of node.right and 0. And after that, we have to update the global maximum path sum if the current path sum is greater than the former one. So the code is max sum equals math.max of the max sum itself and the new current path sum, which is left path sum plus right path sum and node.value itself. Then we have to return the providable maximum path sum that this node can contribute to its parent. And we have to pass the providable maximum path sum back into the previous recursion call. And the providable max path sum is made of the maximum of either the left subtree or the right subtree, and plus the current node's value. So the code is will return node.value and plus math.max of left path sum and right path sum. And that's all of the code. Let's submit it and check for the correctness. Oops. We have to revise the name of the class. Let's wait for the check. Yes, our code got accepted. And then let's analyze the time and space complexity. So the time complexity, it is big O of n, and n stands for the number of nodes in the binary tree, as we visit each node exactly once during the depth first search traversal. And the space complexity is quite different. It is big O of h, and h is the height of the binary tree. And this is the space we used for the recursion stack. And there are two cases. In the worst case, if the tree is a skewed tree, the space complexity can be big O of n, as we'll store all the nodes inside the stack. But in the best case, if the tree is a balanced tree, the space complexity can be big O of log n. So the space complexity is big O of log n to n. And that's all of my LeetCode review one-take vlog for this problem. And I highly recommend you guys to visit my online GitHub page here, which contains all the notes, all the problem description, intuition, solution with code and explanation, and the final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the codes and notes to build this online GitHub page here. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.